Welcome to the American Diabetes Association's Diabetes Core Update, where every month we review the most important articles in diabetes, obesity, and cardiometabolic disease. I'm Dr. Neil Skolnik, professor of family and community medicine at the Sidney Kimmel Medical College of Thomas Jefferson University. And joining me, as always, is my co-host.
I am John Russell. I'm clinical professor of family and community medicine, also at Thomas Jefferson University at the Sidney Kimmel College of Medicine.
And John, we're going to start off today with a wild article on food coloring additives and their effect on the incidence of type 2 diabetes. And this was in Diabetes Care. Then we're going to discuss a systematic review and meta-analysis of automated insulin delivery systems in type 2 diabetes. Yes, I said type 2 diabetes. Then we're going to look at the effect of GLP-1 receptor agonists on breast cancer survival and recurrence. And that was from JAMA Network Open Oncology. Then from JAMA, an article on screening children for early stage type 1 diabetes. Then from The Lancet, the effectiveness and safety of semaglutide in type 1 diabetes. And finally, we're going to talk about another article from The Lancet on tirzepatide for maintenance of body weight reduction in people with obesity in the United States. And we're going to start with the article on food coloring, and the title from Diabetes Care of this article is Food Coloring Additives and the Incidence of Type 2 Diabetes in the Nutrinet Sante prospective cohort. The goal of this study was to investigate the potential association between exposure to food coloring additives and the incidence of type 2 diabetes. The study followed over 100,000 participants with a mean age of 42 from the French Nutrinet Sante cohort during the years 2009 to 2023. Dietary data was assessed using repeated 24-hour dietary records, including industrial food brands. Cumulative time-dependent exposure to food additives was evaluated through multiple composition databases and ad hoc laboratory assays. Associations between exposures to food coloring additives and type 2 diabetes incidence was assessed. There were over 1,100 incident type 2 diabetes cases diagnosed. Mean follow-up was about 8 years. Intake of the following colors were associated with a higher rate of type 2 diabetes. That is total food coloring additives with a hazard ratio of 1.38, meaning a 38% increase in the incidence of type 2 diabetes. The p-value here was equal to 0.0002, so very significant. Other additives, caramel, hazard ratio 1.43, again, same p-value. Plain caramel, sulfite, ammonia caramel, total carotene, different carotenoids, paprika, lutein, curcumin, some other things I can't pronounce. John, your thoughts on this?
It's actually something I have a little bit of an interest in. So prior to 1900, there were all kinds of things that were added to food with regard to coloring, including things like arsenic and coal tar. So there were a lot of things. And then 1906 was the Food and Drug Act. And part of the reason that people kind of stepped in with this new agency that happened during the Roosevelt administration, were oftentimes people were putting coloring in so something would not seem spoiled. So you could kind of hide thing to make the meat look fresher, et cetera, et cetera. So you got to the 1930s. 1938 was the Food, Drug, and Cosmetic Act. And that started looking at a lot of things, banned some flavorings and colorings that were being added. So when you hear like FD&C number 3, that's Food, Drug, and Cosmetic. So that dates back kind of a long, long time. Not A whole lot happened to the 1960s when there were also was some more legislation looking at some of these chemicals that were added. If you look historically, they have tried to tie some things to artificial coloring. And in the 1970s, there was a Dr. Feingold who said artificial coloring caused attention deficit. Since kind of been disproven, although there certainly are studies that look that, you know, things with extra coloring and extra sugar can certainly cause some problems in people who are a little bit neurodivergent. There have been studies that have increased cancer rates, especially to the beta carotenes can potentially, which adds the color to sweet potato and pumpkin and natural flavoring. So kind of an interesting study. When you think about it, when you and I go to the grocery store, everything with the artificial coloring in it is in the middle of the grocery store, though, right? So it's not really with our produce. Hopefully, it's not with our meat and poultry, and hopefully, it's not with our dairy, et cetera. And it's in the center part of the grocery store. And I think one of the things that they completely could not discount in this study out of France is if I'm taking in things that are fairly nutritionally devoid, you know, kids' breakfast cereals and sodas and fruit punches and things like that. If I'm taking in a lot more of that, certainly that's going to lead me to be more likely to develop diabetes and things like that. That said, in some of the data, I don't think you can completely kind of tease some of this out and say this is all soda pop and candy and breakfast cereals and things like that. And it is possible that some of these substances, and they postulate some different ways that perhaps some of these chemicals can impact in their own right some insulin metabolism, leading to some insulin resistance, et cetera. So, we, and in this particular study that was done in the EU, the EU does not allow all the same coloring. They allow less of it than we do in the United States. So, there are things afoot for trying to make people eat healthier. I think the interesting things in this, though, is the natural flavors or colorings, excuse me. So beets can add color to things and, et cetera. The natural colorings were no safer than the synthetic type things. So I think it's an interesting question. And I think if we eat less stuff in the middle of the grocery store, we're probably better off. If we eat kind of less gummies and candy and things like that, we're probably a little bit better off. So I think an interesting study. I do find it kind of hard to blame, everything at the foot of, artificial flavoring and coloring. I think certainly it has a lot to do with what that coloring and flavoring is in. Our next trial is from Diabetes Care, and it looked at automated insulin delivery systems in type 2 diabetes, a systematic review and meta-analysis. So the researchers looked at 9 studies, over 1,500 participants that were included that used automatic insulin delivery systems in patients who had type 2 diabetes that were reported using continuous glucose monitoring outcomes. And they looked in the usual sources, PubMed, Cochrane, Embase, clinicaltrials.gov. Data was collected on study characteristics, and they looked at time in range. That would be sugars that were between 70 and 180. Time above range, greater than 180. Time below range, less than 70. Mean glucose and A1C. And they performed a single-arm meta-analysis using a random effects model. So the AID systems that they gave to the patients who had type 2 diabetes, and certainly we see them used often in patients who have type 1 diabetes, significantly increased the time in range by 16%, changed the time above range by decreasing it 16%, decreased A1C by 1.27, and changed the mean glucose by decreasing it by 21.3 milligrams per deciliter. There was a modest yet significant reduction in time below range, and there were no changes in body weight or BMI. Neil?
John, this is an impressive result. I mean, a change in A1C by negative 1.27% by using an automated insulin system compared to regular insulin. That's about the same change that you get in people when you start basal insulin in people who need it. So this is a big deal. Now, the standards of care this year, the ADA standards of care in 2026, January, said for the first time, this is if people want to look this up, it's section 9.27. And I'm going to quote here, automated insulin delivery systems should be offered to all adults with type 1 and type 2 diabetes on insulin, depending on the person's or caregiver's needs and preferences. And it was given a level A recommendation, largely because of many of the trials that were included in this meta-analysis. Now, I think this would be surprising for many people, certainly in primary care out there, who are using insulin, and often, starting insulin is one of those things many primary care struggle over. And then it's a challenge to titrate, and certainly a challenge to add additional mealtime insulin. It seems intimidating to use an automated insulin delivery system, but I think back, it wasn't that long ago that it seemed intimidating to use CGM, and now it's everywhere. And if we're not recommending it, our patients are asking for it, as they should. And I think that if I were to predict, automated insulin delivery systems will be the same way, that because the evidence is really good that they work, we're going to start using them more. It's going to be like automated driving. As the data accumulates and as we gain experience, it changes from intimidating and from something that we're not used to something that we embrace and eventually will likely become commonplace. Our next article is from JAMA Network Open Oncology, and the title is Survival and Recurrence with GLP-1 Receptor Agonists in Breast Cancer. We know that patients with breast cancer who have comorbid obesity or type 2 diabetes have poorer outcomes, higher recurrence rates, poorer survival than in people who don't have obesity or type 2 diabetes. What this article sought to do is evaluate the association between GLP-1 use and 10-year all-cause mortality, as well as recurrence-free survival over the 10-year follow-up period. It was a retrospective cohort study. They used the Trinex US data set of women over 18 years old who were diagnosed with breast cancer. And this included people from 68 different healthcare organizations, feeds into this data set. GLP-1 use was defined as greater than or equal to 2 prescriptions during the 6 months before and at any time after the index diagnosis. There were over 840,000 patients with breast cancer that were looked at. Mean age was 69, and they looked at 3 different cohorts. They looked at 1,610 patients who had used GLP-1s versus those who did not use GLP-1s and had used them for obesity. So this was the group that did not have diabetes, just had obesity. Then 2,323 patients, GLP-1s versus insulin or metformin. And then 4,052 patients for GLP-1 use versus SGLT2s. Among patients with obesity, GLP-1s were associated with a lower cause of all-cause mortality, and this was not small. This was a hazard ratio of 0.35, or to say it a different way, a 65% decrease in all-cause mortality over 10 years. And the p-value here, again, mind-boggling, less than 0.001. And for recurrence-free survival, the hazard ratio was 0.44, a 56% decrease in recurrence, same low p-value over a 10-year period. Among people with type 2 diabetes, GLP-1s versus insulin or metformin, lower hazard ratio of all-cause mortality. Here was a hazard ratio of 0.09. Again, low p-value, and recurrence-free survival, a hazard ratio of 0.33, very low p-value. There was no significant difference observed between GLP-1s and SGLT2s in people with diabetes and breast cancer. John?
Another interesting study, and I want more. So what does that mean? Well, 40% of cancers in the United States are probably related to being overweight or obese. It's a lot, right? And so is what we're seeing here simply related to some weight loss? So when you kind of tease out some of the data, they really don't list how much weight on kind of average all these patients lost. So in saying I wanted more, I'd love that. The researchers themselves in their own discussion said, we're not really great at having estrogen receptor kind of status in there. So I'd be kind of very interested, were a lot of these cancers estrogen receptor positive, or were they triple negative? So if we lose weight, we lose fat, and there's often estrogen in our adipose that we lose. So I'm interested in that as kind of some more information. And when this study was happening, the GLP wasn't what we think GLPs right now, right? So we think about GLPs as these kind of brand new medicines, and they've had more than 25 years since we had the first injectable GLP-1 Byetta on the market. So a lot of the meat of this study was done in that. And if you kind of dig a little deeper into the data, certainly GLP-1s did better than placebo. GLP-1s did significantly better than insulin / metformin, but they did about the same as SGLT2s. If you think about it, kind of the SGLT2s have some weight loss, oftentimes a little bit of a water weight, but somewhere in the 4 to 6 pound range. And if we think about our first generation, for lack of a better term, GLP-1s that were just for diabetes, maybe they were in that 6 to 12 pound weight loss. So having that being equivalent, because remember, if you're thinking the ominous octet and you're thinking about all the different places that GLP-1s work, they work about 7 of those. You look at the SGLT2s, they work at the other one. So it's not even, if they're going to be equivalent, that they're kind of working on the same receptors and things like that. So enacting in the next incantation of this study, I'd like to see with the more powerful GLP-1s, for the GLP-1s that are purely for obesity. I'd love to see kind of data kind of correlating how much weight someone has with how they do with reduction. All of that said, I think for you and I as clinicians, as we have patients who have diabetes or patients who have some obesity, who are inquiring about, is it safe to take a GLP-1 in the midst of treatment of their cancer? I think the answer would be yes, and it actually might increase positive outcomes. And I think when we're talking to patients for another reason for trying to get to an ideal body weight the best they can, this is also a way for cancer prevention. Our next article is from JAMA, and it's on screening children for early type 1 diabetes. So this was a study that happened for 10 years between 2015 and 2025 on children who were living in Bavaria. They were screened for early stage type 1 diabetes. The screening was conducted by 716 primary care pediatricians. Screening was performed once in children who were between 1 3/4 age and 6 years of age until 2019, and was subsequently expanded to include up to 2 screenings from the children who were 1 3/4 age up to 11. Family of children with early stage disease were offered diabetes education, metabolic staging, and longitudinal monitoring in 18 specialized diabetes centers. So they looked at over 220,000 children with a median age of 3.1 years. About half of them were female, 106,000. 590 had pre-symptomatic early stage type 1 diabetes at the first screening. with an adjusted population frequency of 0.3%, with a prevalence of 0.223 for stage 1 and 0.06 for stage 2 type 1 diabetes. The repeat screening in over 11,726 children after a median of 3.3 years identified another 29 cases. And during a median follow-up of 5.7 years, 200 children with an early stage diagnosis at first screening, 5 with a diagnosis at rescreening, and 43 without an early stage diagnosis developed clinical stage 3 diabetes. 5-year progression from early stage to clinical diabetes was 36.2%, and not significantly different between children with and without a first-degree family history. Neil?
John, this is an important study. First off, to remind our listeners about the different stages of type 1 diabetes, because often, traditionally, we've only thought of type 1 diabetes once it is diagnosed. But stage 1 is defined by the presence of 2 or more islet cell autoantibodies with normoglycemia. Stage 2 is the presence of those 2 islet cell autoantibodies and dysglycemia. And stage 3 is what we typically think of as someone presenting with type 1 diabetes, is hyperglycemia. Now, the ADA currently recommends screening for autoantibodies in family members of those who have type 1 diabetes. But it turns out what this trial saw is that would have caught only about 17% of the total population that they actually found by doing routine screening. Now, let's think about that number that was found, the 0.3% of the population that had pre-symptomatic early stage type 1 diabetes at that first screening. And let's think about it in context of other things we screen for. So newborn screening, things like congenital hypothyroidism, sickle cell disease, cystic fibrosis, others, all have a prevalence of under 0.5%. So in the same ballpark, and many of them even less. The question, though, with screening is always, is there something that you can do about it that makes a difference? And with regard to screening for type 1 diabetes, there are 2 important things. One, alerting family that the child is at risk, because children still present in DKA and very sick. If you're alerted about what symptoms to look for and people stay on top of it, then hopefully those children would no longer present acutely ill. The other thing, though, are all of these new medicines that are in the pipeline that may prevent or delay the development of type 1. So the one that is now FDA approved, teplizumab, is a monoclonal antibody, and it is disease modifying. It delays the onset of type 1 diabetes in people who are found this way. There's others in the pipeline, so it wouldn't surprise me if at some point in the not too distant future, this is discussed and debated about whether or not it should be implemented as a part of population-wide screening for children. For our next article, we're going to discuss an article from The Lancet on the effectiveness and safety of semaglutide in type 1 diabetes. And this is a Danish nationwide cohort study. And it is my absolute pleasure to welcome back to our podcast Ajay Rao, who is an associate professor of medicine and chief of the section of endocrinology, diabetes, and metabolism at the Lewis Katz School of Medicine at Temple University. Jay, welcome back to our podcast.
Thanks so much for having me on again. I really appreciate it.
You know, this article caught my eye when I saw it. Obviously, we are used to GLP-1s for type 2 diabetes, but we're not used to thinking of them for type 1. I know there's been a lot of hope that they'd eventually be available. They're not FDA approved right now for type 1 diabetes, but can you give us some background about why they chose to look at this?
I think, I always think of it in the terms of maybe the patient perspective. If I'm living with type 1 diabetes, I've obviously seen a lot of amazing technology and variety of insulin delivery systems. But for a long time, really the only solution for me, if I was living with type 1 diabetes, has only been getting you some form of effective insulin, whether that's multiple shots or, continuous infusions through, what we call insulin pumps. And if I'm sitting around watching TV or listening or talking to my colleagues, all of a sudden I hear about all these new medicines for whether it be type 2 diabetes or obesity. So I think there's an emerging interest about, how could these potential therapies be helpful for somebody living with traditional type 1 diabetes who's now living a longer life, which is great, but also means the potential for all of the downstream complications for development of those things. So I think it's really important to see the role or understand the role of these newer agents, perhaps for people living with type 1 diabetes.
Those are really important points. How did they go about looking at this in this study?
Yeah, so we're seeing a huge amount of interest in the GLP-1 receptor agonists or other sort of incretin-based therapies for people clearly living with type 1 diabetes. This study it was done in Denmark and by the Danes, and they have a fairly robust healthcare system, which I think is great for their population. So they sort of did a what we call a retrospective study or a look back of individuals living with type 1 diabetes between about, I think, 2014 and 2018, and looked at those who are living with type 1 diabetes who happen to get add-on, they use semaglutide in this study, versus sort of matching them with an equivalent group getting sort of standard of care. And then I think they were really interested in examining what happened with people's A1C results. How did that affect potential A1C lowering? And they were obviously very interested in, adverse events or, things that led to hospitalizations.
That makes a lot of sense. And what did they find?
Yeah, so I think in this, really well-designed retrospective studies, obviously as we all know, the gold standard is prospective randomized studies, which we are starting to see for people living with type 1 diabetes and these newer agents. They did a look back and they were able to show that there was a pretty reasonable A1C drop, about 0.5%, when they looked at this group getting semaglutide and sort of comparing them to about a matched group who were not getting semaglutide. But I think what was also really crucial when you're thinking about these medications is that there was really no increased risk of hospitalization. So, a side effect profile that we all don't want. And then also more importantly, in this group is the risk for hypoglycemia and diabetic ketoacidosis, which was not seen, which I think is really, really great.
Yeah, those are really important results, and that benefit for safety is so critical. And then A1C reduction, you're feeling.
Yeah, so they mentioned it being clinically meaningful. There was about 0.5% drop in the A1C. Obviously these are things that probably need to be teased out a little bit more if it was perhaps prospectively designed or more longer studies. The other things to think about is we don't have other aspects such as time in range, for those who are living with type 1 and using a continuous glucose monitor, because in this study, I think a great thing about this study is it's very much a real world study. So not everybody in this study had to be on an automated insulin delivery device. They actually could be also on standard multiple daily shots of insulin. So, I think the A1C drop is nice to see. I think it would have been greater to see a little bit of a bigger drop. But again, it also could be, due to the design of the study, how long they were on the therapies. And of course, another thing that wasn't really cataloged well is there a chance that there was a total daily dose insulin reduction in the people who are on, obviously on pump or injections.
Good points there. So what do you see as the clinical implications of the study?
Yeah, I mean, I think as you mentioned before, there is a slew of these drugs in the market. We have GLP-1s, we have GLP-1s, GIPs, we have the, triple crintins, we have a lot of things coming down the pipe. And again, if I'm a patient living with type 1 diabetes, I want to know why these aren't for me. I think, the curiosity is still going to be whether there will eventually be FDA approval for these agents. Clearly, though, what we're finding out, though, on a retrospective manner, is that there is a heavy, high off-label use of these agents, which again, the providers have to have that meaningful discussion with the patients that these have not been tested and approved yet by the FDA. But clearly, there's a safety that's clearly demonstrated in these studies, which I think is great. And again, patients are probably seeing the benefits of what others are seeing with GLP-1s, which is, weight loss and better glycemic control.
Fantastic. Dr. Ajay Rao, thank you so much again for joining us.
You're very welcome. Thanks again for having me.
And our last article is from The Lancet, and it looked at tirzepatide for maintenance of body weight reduction in people with obesity in the United States. The SURMOUNT Maintain study, a multi-center, double-blind, randomized, placebo-controlled trial. So this was a phase 3B placebo-controlled 112 weeks trial that included a 60-week open-label weight loss period and a 52-week double-blind weight maintenance period that was conducted across 20 sites in the United States. After patients completed the initial weight loss period with 1 weekly subcutaneous tirzepatide at the maximal tolerated dose, adults greater than 18 years of age who had a BMI of 30 and above, or 27 with one or more weight-related comorbidity, and a history of at least one self-reported unsuccessful dietary effort to lose body weight, were randomly assigned in a 3:3:2 ratio to continue tirzepatide at the maximal tolerated dose, reduce their tirzepatide to 5 milligrams, or switch to placebo for an additional 52 weeks. Starting at week 84, so 24 weeks after the randomization, participants could receive rescue tirzepatide if their weight gain exceeded 50%. The primary endpoint was a percentage change in body weight from baseline to week 112. The primary estimate was the modified treatment regimen estimate, which assumed that participants who initiated rescue tirzepatide would not have gained further benefit from their assigned study treatment, and included all randomly allocated participants regardless of treatment discontinuation or initiation of prohibited medications. The efficacy estimate was supportive. Safety was assessed in all participants who received at least one dose of study drug. The study, which went on from September of 23 to January of 26, there were 441 patients who were enrolled and took at least one dose of study treatment during the weight loss period, with 378 participants who were randomly allocated at week 60. 140 were on the maximal tolerated dose, 144 to the dose reduction to 5 milligrams, and 94 to placebo. 372 received at least one dose of study drug during the weight maintenance period, 139 for tirzepatide maximal tolerated dose, 142 for the 5 milligram tirzepatide, and 91 for placebo. 345 or 91% of the 378 participants completed the study. The majority of participants were white, 2/3. 65% or 288 were female, and the mean age was 46.6 years. At baseline, participants had a mean body weight of 113.8 kilos, a BMI of 40.1, and A1C of 5.64. The model-based estimate percent change in body weight from baseline to week 12 was a decrease in 21.9% with maximal tolerated dose, 16.6% with 5 milligrams tirzepatide, versus a decrease in 9.9% with placebo. Among participants who gained at least 50% of lost body weight observed were 11%, or 11 or 8% of the 138, 35 or 25% of the 142, and 60 or 67% of 90% participants received rescue therapy in the tirzepatide in the maximal tolerated versus 5 milligrams versus placebo, respectively. The most common adverse effects with tirzepatide were GI events, which were mostly mild to moderate in severity and mostly occurred during dose escalation. Neil?
John, this is important information. I think we're all struggling to figure out what to do after someone's been on their titrated dose of a GLP-1, they've been successful. It's now a year or 2 years or 3 years into treatment. And then what? We know from earlier trials, both in the STEP trials and the SURMOUNT trials, that when someone is just discontinued from their active GLP-1, they begin to regain weight very quickly. So that does not usually work well. The question is, what should we do? Do we need to continue the dose, the high dose that got them to the weight loss? Or can someone be maintained on a lower, possibly more well-tolerated dose versus what happens if you stop the medicine entirely? And this begins to answer that question that we're all struggling with. Clearly, the people who stayed at the dose that got them there kept off the most weight, about 22%. But the tirzepatide 5 milligram group did pretty well. They kept off approximately 17% of their weight. Now, I want to be careful that people understand the placebo group that appears like they kept off 9.9% of their weight did not actually do so because, as you said, there was a rescue treatment built into here. If once someone regained at least 50% of their lost body weight, they were restarted on active medicine. And that happened with 2/3 of the placebo group. So if you think about it, if everyone, and what they used was the last number carried forward, was the statistical term for how they got to that 9.9%. So if you think about it, if you start at about 22% weight loss, and everyone, even if everyone in the placebo group required rescue therapy, it would look like they only went down to about 10%. So placebo group did not do well, which doesn't mean no one, but it means the vast majority regained a good portion of their weight. So what does this tell us? It tells us for a lot of people, we're going to be able to titrate that dose down. Now, next month, we're going to talk about the ATTAIN-MAINTAIN study of oral orforglipron as a medicine transitioned from either Zepbound or semaglutide use. We'll go over those results next month. It came out too late to be included in our discussion today. But we're going to be in a world, John, where once someone's been on a good dose of GLP-1, has been successful, we'll have multiple options that'll include primarily continuing the same dose, going to a lower dose, or switching to an oral medicine. And we'll need to, this is where clinicians like you and I become so important in following patients closely, seeing how they're doing, and tailoring those decisions to the individual. For more information and links to the articles that we discussed in this issue, just go to diabetesjournal.org. Until next month, keep listening
and keep learning.